We'll be starting with different memory management techniques. We'll be understanding three ways. First is the manual, the garbage collecting way, and the ownership model of REST language. Before starting, I have to tell one point, that is anything which is loaded onto the stack is deleted, is reallocated automatically when it goes out of scope. So regardless of the language, the stack is automatically managed. These memory management techniques are only for the heap memory. So we have to keep in mind that everything which we cover from now on is happening in the heap memory. So let us understand the C++ way. So in C++, you have to allocate and deallocate every memory yourself. This can lead to dangling pointer or memory issues. We'll be understanding what these issues are. And the third point is that the learning curve is very high since you have to do everything yourself manually. Uh, the second is the go way, which is the garbage collector. So what garbage collector is, uh, during runtime there are garbage collecting cycles which looks for uh, any dangling pointer. If there is any dangling pointer, then data is automatically deleted. And this garbage collector is usually a program which is run during execution of the program, so it is a different program. All right. And the third is the rest way, which is the ownership model. So it brings some new things to it, that is ownership, borrowing, lifetimes, moving. And these concept really helps the Rust language to make it really fast and safe. So we'll be understanding each of them here. All right. So we'll be starting C++ memory management techniques. If you see the title, it is how are they different from C++. That is because we'll be understanding C++ first, but I made Go management and Rust management uh, previously in my slides. So it is better to understand C++ first and then Go and Rust management. All right, so we'll be starting with C++ management. If you if you see the below code, you can see on line number 6, we allocate a memory on the heap to the pointer p, and on line number 7 we assign the value 42 to p, and in the code thereafter uh, it is commented. And on line number 14, as the main function goes out of scope, the pointer p, which was loaded onto the stack frame, will also go out of scope and the stack frame will be deleted. But the line number 12, as it was commented, the data inside the heap will also not be deleted, hence creating a memory leak. So memory leak is an issue if it is done for a larger data. If a larger data has been memory leaked, then uh, it may create issues for the other programs which are running, and that will lead to lags and crashes of your programs. All right, so this is what a memory leak is. And if we try to, just a second, if we try to uncomment this code and uncomment delete p, then what happens is we will delete this data, and after the scope ends, the heap and the stack will all be free, and the memory can be used for other programs too. So this is how you manage memory in C++. As you can see that it is a programmer's responsibility to always free the memory. So is it an issue to manually manage C++ memory? We can answer that using RAI method. Alright, so what RAI is? RAI is resource acquisition is initialization. So it is just a pattern or a standardized way in how you can manage resources such as files, memory, and sockets. So consider an example. In C++, you created a class which can manage a file in its constructor by opening it. So you must mandatorily create a destructor which will always close that file. So this is how you can manage whenever the object for that class goes out of scope, it will automatically be deleted by calling the destructor. So memory management can be avoided, not avoided, can be managed using the RAI method. If you want to learn more about RAI, you can check out this reference